All right, guys. So as we are again further digging into this set of skills, guys, the date today, where's the date on my watch? There it is. The date today is the 13th. The topic for the notes today, guys, is writing the formulas for what we call complex salts. So guys, here's what you're going to see. The same rules, finding charges, least common multiples, finding where they match, all that stuff. None of that changes. We just need to bring into the conversation a brand new type of ion. So guys, we're going to do that, and then we're going to talk about a couple little changes, and then guys, you're going to actually probably get your homework done. So guys, today what we need to do in order to talk about what we call the complex salts is we need to learn about what are called polyatomic ions. Guys, I would encourage you to write this down. So guys, in order to talk about complex salts, we have to talk about what are called polyatomic ions. So allow me to define this for you. Guys, polyatomic ions are simply molecules that have a charge. Last time in class, we talked about the elements that have a charge. The positive ones, the metals are on the left. The negative ones, the non-metals, are on the right. But guys, today we're going to talk about a brand new class of ion that are called the polyatomic ions. But guys, if you think about it, poly means many. Atomic obviously means atoms. So if we have many atoms bonded together, we're talking about molecules. But guys, here's the tricky bit. You already know all about these polyatomic ions. What you don't know is their names. So guys, let me get started with you. Remember this? Guys, this is the last page of the first homework assignment that we did when we learned 2 units ago to write the names, the domain geometries, the molecular geometries, and the angles for these molecules. But then guys, remember that we drew these in brackets and we added a charge to them. What was going on? Guys, these are what are called polyatomic ions. So they have a charge, that makes them an ion, but they're polyatomic, so they're molecules with a charge. And guys, those are the things that we use to create what are called complex salts. So guys, here's the deal. You don't have to memorize any of this. You don't have to be able to regurgitate any of this until AP. Guys, in this class, you get a list of all of them, and you get to use this for the rest of the year. When you lose this, there will be extra copies over there. Once those are gone, they are posted on our website. But guys, my encouragement to you would be to keep this near your periodic tables. Because guys, what you're going to find is for the rest of the year, you know how we normally say, hey, grab your periodic tables. Now it's going to be grab your periodic tables and your ion charts. So guys, let me give you a moment to familiarize yourself with these. And then we're going to talk over how this is organized, figure out how to use it effectively. And then guys, we're going to write the formulas for a couple complex salts. Then there's one more thing to talk about, and we are going to dig into homework. So guys, just allow your eye to scan around the page. Remember, gang, we have been talking all year about structure and patterns and organization. And guys, even just glancing at this without reading the words, you see that there's structure and there's organization, because that's what tables do. But now, guys, let's dig a little deeper. How is this table organized? What do all of the ions in a cell have in common? Tell the person next to you, what do all the ions in a cell have in common? Do you see it? Guys, if you're not sure, what would your eye draw you to in order to answer the question? The headings. You'll notice they're in bold. And what are all of those headings? Charges. So guys, all of these ions are organized by charge. So then guys, allow our eyes to scan around the table. In the upper left-hand corner, you'll notice we've got one ion with a +1 charge. And guys, understand that you can write it +1 or 1+. In AP, we talk about the difference. In here, it doesn't matter. 1+ or +1. Either one is fine. So guys, we have one ion with a +1 charge. It's ammonium. Then you'll notice in the upper right-hand corner, we have two ions that have a +2 charge. One of them is what we call mercury 1, and the other one is what we call mercury 2. Guys, we're not going to deal with those ions very much. But then guys, look below. Holy smokes. We have a ton of ions that have a -1 charge. We have almost as many ions that have a -2 charge. And then interestingly, we only have one ion with a -3 charge. Guys, understand this list is not complete. These are the ions that you'll need to know for AP next year. These are the common ones. So these are the ones that we introduce you to. There's actually dozens, if not hundreds. But guys, these are the common ones. These are the ones that you're going to see mostly when you get to college. These are the ones that we'll deal with in here. So now guys, with that in mind, do this. If you turn your attention to the screen, guys, you'll notice that in these ions on your paper, it not only has the name and the charge, it also has the formula. So guys, now we need to get good at finding these formulas on the paper. But guys, notice this. The first way you can figure out where you are is simply by looking at the charge, because the charge tells you which column you're in. So guys, find the name of the first ion that's up on the screen. So we know it's in the -1 column, and we know it's OH. Guys, what's the name of that? Hydroxide. Guys, this is the hydroxide ion. So later in the day, you're going to see something like sodium hydroxide, and you're going to know that's a sodium ion and a hydroxide ion. So guys, the first one is hydroxide. Find the second one. Now, where are you going to look? You know, because of the charge. Then guys, allow your eye to scan down the column, and guys, what is this ion? Nitrate? Nitrite. Guys, be careful. Find nitrate and nitrite on your paper, and let me help you understand the difference. So guys, what is nitrate? NO3. Nitrite is NO2. Guys, let me give you the decoder. Ite means less oxygen, and ate means more oxygen. It doesn't mean 2 or 3, it means less or more. You don't need to know that, but it does make it more simple. For example, if you look in the -2 column, find sulfite and then find sulfate. Guys, you'll notice that sulfite is SO3 and sulfite is SO3 and sulfate is SO4. So again, it doesn't mean 1 or 2 or 2 or 3 or 3 or 4. It means less or more. So guys, this is the nitrite ion. Nitrate would be NO3. Is that okay? Then guys, this one's easy. -3. Only one choice. Phosphate. And then guys, this is a little trickier. So it's in the -2 column, but you've got 2 carbons, 4 oxygens. Do you see it? This one I don't know. Is it oxalate? Is that true? This is one I don't have memorized because we don't use it much at all. Is this oxalate? Is that right? Okay, so guys, that was phosphate. This is oxalate. Do you feel comfortable enough with this chart that, and I know you're just kind of getting used to it, but do you have a sense of organization so you can use it to write salts? We okay? All right. So guys, with that in mind, let's talk about how we're going to do this. I don't know if you need to write this down, but maybe you should at least think through it with me. So guys, as you allow your eye to scan through all the names on this yellow chart, do you notice that most of them end in ate and ite? Except for which 3? Do you see them? Not the top ones, the bottom ones. Which ones don't end in ate or ite? So hydroxide, cyanide, and peroxide. Guys, these are the ones that are going to confuse you. Guys, follow the laser with me. If we have a salt that contains oxygen, we call it oxide. This is sulfide. This is chloride. This is fluoride. This is selenide. This is iodide. This is bromide. Guys, we are used to the ions ending in IDE. So how do you know if it's not an ion, but it's on the yellow sheet? And guys, the answer is it'll end in ate or ite with 3 exceptions: peroxide, cyanide, and hydroxide. Guys, I would underline those so that they jump off the page. So the big idea then is this: if it ends in ate or ite, it'll be on the yellow sheet. If it ends in "ide," it will be an element, unless it's cyanide, hydroxide, or peroxide, and you just need to keep track of those. So guys, these normally end in ate or ite, with the exception of hydroxide, cyanide, and peroxide. And again, I would encourage you to underline those. You guys good on that idea? All right. So now, guys, think through this with me. What are the steps for writing chemical formulas like we did on the previous homework? Step number 1, write down the formulas. Step number 2, charges. Step 3, least common multiple. Step 4, how many of each ion do you need? Step number 5, subscripts. Yes? Guys, we are doing exactly the same thing today, only now we're going to do it with polyatomics. So we treat these, you don't need to write this down, we treat these just like any other ion. Hey, grab a periodic table. We treat these just like any other ion. Guys, with one exception. So again, just like any other ion, their charges have got to balance. The only difference is this: if you need more than one, well, that's crazy. If you need more than one polyatomic, guys, you put it in parentheses. And if you only need one, do not use parentheses. So guys, that is the only new thing coming at you, and it's all about parentheses. I'll drive this home with you in a minute, but guys, this is the only thing that makes this different, is the use of parentheses. So guys, if you can just remember the word parentheses, you're going to figure this out pretty quickly. Seems as if some of you are scratching it down, which is fine. If you're not, I don't think you need to. We were going to look now, guys, at 4 examples of this. And then you're going to get your homework done. It's a beautiful thing. Can I just show you examples? Is that all right? Adam, are you okay? Are we all okay? Okay. So guys, we're going to look at 4 examples, and then we're going to get you going on homework. So guys, I would encourage you to write these down with me, and let's play with them. So the first one we are going to do is what is called calcium sulfite. Guys, we have this mineral up in our hills. It's not limestone, but you find this stuff collecting where limestone collects. Limestone is actually calcium carbonate, whole different deal. But guys, if you've ever been up into Timp Cave and you've seen some of the interesting colors in that cave that are not white, some of that is actually this calcium sulfite. So guys, let's figure out what calcium sulfite is. Step number 1, write down the formulas. So guys, find calcium on your periodic table, and you find it all the way over here on the left, but we know it's going to be on the left because it's first. And guys, calcium is Ca, and so long as we're there, let's get the charge. It's +2. Guys, please stop me if you need to ask questions. Rachel, this is what you missed last time, so if what we're doing makes sense, you're going to be good on the previous assignment as well. Okay. All right. So now, guys, we need sulfite. How do we know that's not sulfur? How do we know it's not the element sulfur? It ends in ite. Guys, if it ends in ite or ate, it's on the polyatomic ion chart. So guys, we've got to scan around. Do you guys see sulfite? It's like almost exactly in the middle of the page. What is its formula? SO3. And what is its charge? minus 2. So guys, this is SO3 minus 2. So now guys, we got to do the least common multiple. We've got plus 2, plus 4, so on, minus 2, minus 4, minus 6, and so on. Guys, where's the first place those meet up? 2. So guys, how many 2's make 2? 1. We need 1 calcium. Now how many minus 2's make minus 2? And guys, the answer is 1, so we need 1 of these, so that would be CaSO3. That is calcium sulfite. So guys, if that one seemed a little strange to you, let's do number 2 and then answer questions. And I think you'll find just seeing one more example makes these come together a little more cleanly. So now guys, let's do this. Magnesium nitrate. I'm going to grab a thinner pen. There we go. All right, so guys, is it element 12? Is that right? Off on the left. Hey, guys, magnesium is Mg. Its charge is plus 2. It's element number 12 if you can't find it. Then guys, where do we go to find nitrate? Is it on the yellow or the periodic table? It ends in 8, so it's on the yellow sheet. Guys, what is nitrate? NO 2 or 3. Careful. NO3. Guys, be careful with the polyatomics. A lot of times they only differ by 1 oxygen. So nitrate is NO3 and its charge is minus 1. So guys, let's see if we can do this in our head. Where do 2 and 1 meet up? 2. So guys, how many magnesiums do we need? 1. How many NO3s do we need? 2. Now guys, watch. How do we communicate this? Well, magnesium, we just need 1. So we're just going to write down magnesium. But then guys, we need NO3s. But we need 2 NO3s. As a result, we put the NO3 in parentheses and we drop a 2 on there. Because that is the only tricky bit about this stuff is the use of parentheses. So let's talk. Why does this not have a parenthesis around it? Because you only need 1. Why does this have a parenthesis around it? Because you need 2. Does that work? We're going to do 2 more and we're done. All right, my board's going to freak out again. Bear with me. All right, so guys, the next one we're going to do is nickel 3 hydroxide. What did you learn last time? What does the 3 tell us? Plus 3. It's the charge. Guys, we just looked at this randomly. Guys, nickel is plus 2 and plus 3, right? You guys said not plus 6. I thought it was also plus 6. Is it just 2 and 3? Okay, so guys, nickel is 2 and 3, but at the end of the day, we don't need to look it up because we know we're using the plus 3. So the Roman numeral tells us the charge. Now guys, this is a tricky one. It ends in "ide," and when we have something that ends in "ide," we're thinking, oh, wait a minute, that should be an element on the periodic table. But guys, it's not. It's one of the 3 that you underlined. What is hydroxide? OH. Its charge is minus 1. So guys, check this out. Hydroxide is OH minus 1. So where do 3 and 1 meet up? At 3. How many nickels do we need? 1. How many OHs do we need? But watch, guys, I'm going to do this wrong. Just watch. So we need 1 nickel. So that would be Ni. Then guys, we need 3 OHs. Talk to me about why that's wrong. Go ahead, Brad. Good, because that 3 only applies to the H. Guys, what if we need 3 of the whole thing? Then it's got to go in parentheses. Guys, that's why we use parentheses, because it's telling us 3 of the whole package rather than just 3, as you said very well, of the hydrogen. Starting to see the parentheses game? Okay, we're going to do one more, guys. This is going to wrap up our practice. And then, gang, you're going to have the opportunity to get your homework done today. So, guys, the last one that we are going to do is ammonium nitride. So, guys, let's go slow. This one's sort of nasty. So guys, first of all, ammonium, it's first, so we know it's a metal, right? So your eyes are scanning across the periodic table. Oh crap, I can't find ammonium. Guys, it's on the yellow sheet. Upper left-hand corner. Guys, ammonium is one of the 3 polyatomic positive ions that we will use in this class. So guys, do you see it there, upper left-hand corner? So guys, ammonium is NH4 and its charge is +1. Now guys, it gets worse because now we need to find nitride, and your eye is going to scan all around this yellow sheet going, where is nitride, where is nitride? But then you step back and you go, wait a minute, this ends in "ide." And if it ends in "ide," it's only going to be on here if it's cyanide, peroxide, or hydroxide. And you're like, all right, it's not one of those. So that means that nitride is an element. Remember, take off the ending and add IDE. So what element is nitride? Nitrogen. So guys, we come up here and we go N for nitride, and now we need to know the negative charge. Do you remember the game? Guys, nitrogen can be -2 or -3. Which one have we agreed we're going to use? Do you remember? So guys, the idea is this. Nitrogen can be -2 or -3. Here's what we're going to do. Nitrogen has 1, 2, 3, 4, 5 valence electrons. So if it's got 5 valence electrons, it wants 1, 2, 3. And that would give it a charge of -3. So guys, for nitrogen, we are always going to use -3. So now, gang, this. Where do 1 and 3 meet up? At 3. So how many ammoniums do we need? 3. How many nitrogens do we need? 1. So guys, we're going to go NH4, then parentheses 3, and that gives us 3 NH4s, and then N for nitride, and we are done. What do you guys think? Thoughts or questions? Harrison's giving me the big thumbs up. You guys good? Okay. So guys, one more thing really randomly to throw at you. But guys, this is the best time to do it. We could do this on Wednesday, but it's a short day. So guys, let's just do this right now. So guys, remember the progression. Now we know how to write the formulas for the complex salts. On Wednesday, we're going to learn how to name all these things. Then we have a 4-day weekend, and then when we come back on Monday, we're doing a lab, right? Guys, flip this table, the yellow sheet, over on the back. So guys, I need to introduce you to a new concept. It's called solubility. Guys, solubility is simply an indication of whether or not something dissolves in water. So guys, please don't write any of this down, but let me at least let you look at it while we talk about it. So guys, solubility is a measure of a substance's ability to dissolve in water. So guys, now familiarize yourself with this chart. Looking across the top, S is soluble. That means it dissolves. P is slightly soluble. We call it P because we really call it partially soluble. I is insoluble. That means it doesn't dissolve. Like sand doesn't dissolve in water. Then guys, the next one, D, means decomposes. For our purposes, that looks just like dissolving, so we're going to count it as the same. And then a dash means that this salt does not exist. Then guys, notice the left-hand column. What all the things in the left-hand column have in common? They're all positive. What does the top have in common? They're all negative. So guys, bringing the positives and the negatives together makes salts. So guys, let's do this. This is a term we're going to come back to when we do the lab. It's called precipitate. That simply means a substance doesn't dissolve. So guys, let me just run a couple past you. Potassium hydroxide. Does it dissolve in water? So guys, find potassium on the left. Find hydroxide at the top. Bring them together. What letter do you see? You see an S. Does it dissolve in water? Yeah. Now guys, don't be scared. But I may as well preview this for you because I know some of you are coming back for AP next year. Guys, next year in AP, you have to memorize this entire table. But guys, here's the deal. You can do it in 4 concepts. For example, this. Guys, look at potassium. You see it? Allow your eye to scan to the right. What are all of those letters? S's. Now look at sodium. Allow your eye to scan to the right. What are all the letters? Yeah, they're all soluble. You guys ready for the bigger principle? Guys, look. Potassium and sodium. Is lithium on here? It's not. But guys, any salt that contains a group 1 metal, they are all soluble. So you just memorized a big part of the periodic of this table just by knowing that all the group 1 metals are soluble. Now guys, do this. Look at the very top and find nitrate. See nitrate? Allow your eye to scan down that column. What do you see? They're all S's or decomposed, and that looks like dissolving. Guys, all nitrates dissolve in water. Then guys, look down the acetate column. Guys, all of those dissolve in water with only 2 exceptions. So guys, the bottom line is this. You can summarize this table in 4 rules. Each of those rules has slight exceptions, but this is not as daunting as it looks. Let's keep going. All right, so guys, what about this? Cobalt chloride. We find cobalt on the left. What do you got? Bring it together with chloride. And bring them down, soluble. So guys, cobalt chloride dissolves in water. Now this one. Guys, what about something like FeC2O4? C2O4 is oxalate, right? Then you bring iron together. What do you got? Soluble or insoluble? Why are you hesitating? There's 2 irons. And guys, which one is it? Is this iron 2 or is this one iron 3? Guys, let me show you quickly the answer, but we're going to talk more about this on Wednesday. So guys, in order to figure it out, and if you don't understand this, we're going to go deeper on Wednesday. But guys, it goes like this. What is the charge of oxalate? Minus 2? So guys, this is -2. How many oxalates are there? There's 1. So this charge is -2, so this charge is +2, and that would make this iron with a +2 charge, and then you can figure out whether or not it dissolves in water. So we'll talk more about that on Wednesday. So guys, again, the big idea today was dealing with polyatomics. Questions about the parentheses, same skill set as before, just parentheses, and then watch out for hydroxide, cyanide, and peroxide. You guys okay? All right, you're not going to like this. Grab your homework packet. Turn to page 2. So guys, here's the deal. This is actually 2 homework assignments. You'll notice across the top it says names and formulas. Guys, the left-hand column, you have been given the names and you're writing the formulas. The right-hand column, you're given the formulas and you're going to write the names. Guys, that's for Wednesday. So this right column you can't even touch. The right-hand column is for Wednesday. Guys, the left-hand column is for today. But how about if we only do the odds? Or do you want to do them all? Let's just do the odds. But guys, we run into a problem. Not only are you writing the chemical formulas, you're also indicating whether or not they are soluble. So guys, look at lithium cyanide. We have a problem. Grab your solubility chart and answer the question, is lithium cyanide soluble in water? How do you know? I love what you're, Nora, you're amazing. Guys, Nora's going, heck yeah, it's soluble because it's a group 1 metal. But guys, understand, I'm not expecting you to understand those general principles. That's an AP. I love what you're doing though. Guys, on the back of this table, is lithium cyanide soluble? We don't know. Why not? Lithium's not on here. So guys, what we're going to do is we're just going to write down NG for not given. So is lithium cyanide soluble? NG, it's not given. Nora, you're right. It is soluble. But guys, if it's not on the table, just put NG for not given. So guys, that's your homework. You have 40 minutes to do it. We're only going to do the odds. Guys, my strong advice to you would be do this on another sheet of paper. You need room to write big and write well. Guys, I will put the answers up on the wall. Please ask questions if you need. This is what we're doing for the rest of the day. Guys, give me 5 minutes to just get settled a little bit. And then if you need me, I'd love to come and help. But guys, dig into this. That is all.